Alright, hey guys, so today we're going to be going over what is slope and what is a tangent. So we'll start off with what is a slope. So if we take a simple function, for example, f of x is equal to 2x, and we plot the graph of this function, so we know roughly that it looks something like, let's do a quick plot of the graph. There, there. Something roughly like this. So that's what 2x is. And we can see that as x increases, sorry, this is x here, f of x, and as x increases, f of x increases at a constant rate. And we also know how to calculate the gradient of this line, and that gradient is equal to rise over run. It's equal to rise over run. So, what does this mean? This means that the slope of this graph is also rise over run. So, if we look from x is 0 to x is 2, we can see that the graph moves 2 to the right, so the run is 2, so run equals 2, and it rises 4 as x goes across 2, f of x rises 4, so rise equals 4. So the gradient of this graph is equal to rise over run equals to 4 divided by 2, so the gradient of this graph is 2. And this makes sense because we can see it in the formula that f of x equals to x, which is in the form of mx plus c, where c is 0, so which is the same as 2x plus 0. So this is what this graph is. Its gradient is 2. So the slope of this line is 2. So it's easy enough to calculate what the slope is on a graph which is fairly straightforward, like this one. But if there's a more complicated graph, which the slope is constantly changing, so for example, this is just an example, something like this. There's no real way to calculate the slope as a whole, because if we take rise over run, and if we take x across and y up, the graph actually goes down and the slope's changing constantly. So what is useful to do is take a tangent line. So if we redraw this graph over here, just roughly, so what a tangent line is a line that's parallel to, well, if you imagine going along this curve, and then at one point or another, the line just goes straight out from that point, and then you can draw it back across. So at this point here, this is the tangent line. It's just the line that's like parallel to the curve at that point. And what the tangent line tells us is it tells us the slope at that exact point. So at this particular point here, the slope of this point will be the gradient of this tangent line. And this makes sense because we know that we can calculate the gradient of this tangent line with the formula rise over run, and then that just corresponds, because it's parallel to that point here, then it corresponds to the gradient being the same for this. So if we look at this point here, for example, we'll just call it -1. So if we draw a parallel line, so a tangent line to this curve here, we can see that it doesn't rise anything. Well, my bad drawing makes it look like it does, but it's not supposed to rise anything, and the run is just, well, however much you take. So we can take it to be the run of 2 and the rise of 0. So then the gradient at is x is equal to -1 is rise over run. So gradient is equal to rise over run, which is equal to, because it rises nothing, so 0 divided by whatever number you choose. So we'll just choose 2, because we'll take from -2 to 0. So this tells us that the gradient at this point here is 0. So you can do this at any point, really. So we could do it at this point. If we take this point here to be 3 and this point here to be 2, we'll move across to here and roughly we'll call this 3 and 2. So we can see that the gradient of this line here is going to be rise. So it rises 1. So the gradient equal to rise over run, which equals to 3 minus 2. So that's how much it rises. So it rises by 1. Divided by how much it runs by. So that's also 3 minus 2. So the gradient is 1 over 1, which is 1. So the gradient between here, the gradient of this line here, so that's at this point here, is just 1. And you can see that visually. It's a positive because it's constantly increasing. And yeah, it's not quite a steep slope, it's just a gradual. So that's how you calculate the slope. You use the formula rise over run. And a tangent is basically just a line parallel to a particular point on the graph. So we'll just do another example of picking a tangent line. So if we have a graph, just something like this, something simple. We can take the tangent line at lots of different points, and we can see that here it's going to be roughly like that. It's going to change to be like that, to that. So it's going to constantly change like that again. So these are the tangent lines. And you can see that the gradient here of this tangent line is going to be around, we'll just call it -2. This one will be around -1. This one positive 1. And this one around +2. So you can see that it follows the trend of the graph, the tangent lines do, because the gradient's decreasing here and it's gradually getting to a slower decrease. It'll get to 0 here and switch to a positive increase. So basically the tangent lines just tell you the gradient of the curve at a particular point. Hopefully that all made sense. Thanks.